All right, well, video 2 worked fine in class, but video 1, somehow something went bad. So anyways, I'm going to quickly take you through what we did in class here, okay? Today we worked on non-rigid transformations. Non-rigid means it's going to cause some type of distortion in it. We're going to see a different shape of the parent graph. All right, so what causes that? You're looking for an a value out front, okay, or a multiplier out in front of the function. Okay, you don't have to worry about the horizontal stretch or compression. That's going to come up more so in our trig units in chapter 4. So we're going to hold off on that for now, okay? So we just have to focus on the vertical stretch and compression. And when A is greater than 1, it makes it skinnier. When it's between 0 and 1, it makes it wider. Quick little demo on this. Okay, so if we compare y equals x squared to an a value between 0 and 1, this should compress it. It's going to kind of squeeze it down. So here's the graph. Let me start with something greater than 1 so that we can see it see it in action. So there's a parent function, and here's 3x squared. All right, so imagine taking that parent function, and it's a string, and I pull on the ends of that. What is it going to look like? It's going to make it skinnier or stretch it vertically, okay? So when a is greater than 1, the graph appears more narrow or skinnier as we pull those strings up. Now the compression is just the opposite. So I'll throw in a number between 0 and 1, like 0.5. Isn't cooperating. There we go. And imagine taking this parent graph now and squeezing it down. If I squeeze it like a slinky, what's going to happen? It's going to compress it and make it wider. And that's why they call it compression. Okay? Makes it wider. All right, so quick little demo on that. There it is. So the directions for 8 and 9 say to compare this new function with its parent function. And the parent function is included in your notes. Okay, so on day 1, we came up with some coordinates for the absolute value function. Here's a couple that we were using. All right, so to get the new graph, here's the step. Okay, now this is already done, but in class, I gave them some time to write this down. So you might want to pause right now and write this down. Vertical stretches or compressions, what's your transformation step? How do you get these new coordinates? Here's the answer to that. We multiply the y values by a. The x value is unchanged. Keep it the same. Okay, so like I said, pause if you need to write this down. I'm going to continue though. So this a value of 3 becomes a multiplier. I multiply these y values by 3. So that's why the new coordinate is going to be 2, 6. X is unchanged. Same thing here. -2. Positive 6. Okay, and obviously when you multiply 0 by the 3, you still get 0, so that coordinate stays there. Okay, so there's a stretch, made it skinnier. 9, students tried this on their own. Okay, so now I take these coordinates from the parent function and I'm multiplying it by 1/3. So 2 times 1/3 is 2/3, so I'm not quite to 1 here. Or if you like this cleaner number, then use 3, 3. Because 1/3 of that is 1, so we have 3, 1. Do the same thing on the other side. So we have a compression for the graph. Or we say it's compressed by a factor of 1/3. Okay? All right, taking you through this again real quick. Next page. Now we're kind of putting this all together. There's going to be multiple transformations, sometimes 2, 3, or 4 steps. All right, so when you're breaking down these steps, graphing them in stages, follow your order of operations. Otherwise, sometimes you get the wrong graph. So for 10, we start with the parent function, x cubed. Okay, came up with some good coordinates. Now we start transforming those. So parentheses is first, right? So the x minus 2 is in parentheses. That becomes my next transformation. That's a horizontal shift. I took that coordinate, moved it right 2 units. So 4a, and so on, over 2, over 2. Okay, and then the last step, The negative 1 out front is a multiplication step. So I multiply these y values of 8 by negative 1. So that's why this is down here at 4, negative 8. Did the same thing with this one. Reflected it. Okay, so you can use a reflection rule for a negative out front or treat it like an a value. Okay, and this next one, here it is. Here's the steps. We multiply before we add and subtract. So there are no parentheses this time, so I'm just choosing between these. Okay, so I got to multiply. If you do this in the wrong order, you get the wrong graph. Okay, so the first step is a stretch. So at 2, 4 becomes 2, 8. And then we shift that down 4 units. This coordinate goes down 4, that goes down 4, and so on to get the final answer. Okay, if you do the wrong order and you do the vertical shift first, this is what happens. Okay, shift down 4, then multiply all these by 2, and I get the wrong coordinates. 0, negative 8 is not supposed to be on the graph. It is if you do the wrong order. So that's the wrong one. This is the right way. Okay, you can skip 12 for now. And then we went through these generic graphs. Once again, now I don't have a parent function like absolute value or square root. We're just using what they give us. Okay, so we have a negative inside the function. It's different than when it's outside. In day 1, we went over the difference. This reflects over the y-axis. When it's on the outside, it's over x. So that's all they're asking you to do in part A, is reflect this graph. Okay, B, it says 2 steps. So we shift it to the right one. So that's what I did first. Over, over, over to get this blue graph. And then the red graph was the stretch, multiplying the y values by 2. Okay, pause as needed. And then we did C as well. Here's the order. If you mess up the order on C, you get the wrong graph again. So we should do the multiplication, the negative 1 times first. So it takes that graph and reflects it over the x-axis. So that's flipped over, this is flipped over, and you get this blue graph. Okay, then we finish with the vertical shifts. Okay, all right, hopefully that wasn't too fast for you, but like I said, you can pause where you need to. It's supposed to be a 15-minute video, but something happened on the download. So have a good day. Talk to you later.